All right, so let's look at how we would solve some inverse trig function equations when we're using an identity, right? So again, some little steps: isolate the inverse trig function that contains that variable and apply the inverse to both sides and solve for our variable. So seems pretty straightforward, kind of exactly what we've been doing. So let's see what that first example is. So again, we want to solve for x. And so here's our first example. Inverse of sine of x plus the inverse of tangent of root 3 is equal to 2 pi over 3. Okay, so again, first thing we want to do is we want to isolate the trig that has the variable in it, which is this guy. So I'm going to move that inverse over to the other side. So it's going to look like this. So 2 pi minus the inverse of tangent of root 3. Apply the inverse to both sides. So let me apply the inverse, so sine to both sides. And I'm going to get x is equal to sine of 2 pi over 3 minus the inverse of tangent of root 3. So hopefully what you're noticing is that this kind of looks like a sum and difference of sine. So I'm going to make a quick little let statement. So I'm going to say let theta equal the inverse of tangent of root 3. Notice that I did not take that negative with it because I don't want to take the negative with it. I want to just leave that alone, right? So now all of a sudden I have this. X is equal to sine of 2 pi over 3 minus theta. So again, one way we can solve this, we can say sine of 2 pi over 3 cosine of theta, keep the sign the same, cosine of 2 pi over 3 sine of theta. Problem is we need to know what theta is, so let's go back over here. So I'll do it in blue. So tangent of theta is equal to root 3. Again, this used to be an inverse. We only want to look at quadrant number 1, okay? And so when I look at quadrant number 1, there's only two things that are going to give me root 3. It's either 1/2 comma root 3 over 2 or root 3 over 2 comma 1/2. And again, I'm going to be dividing y by x. So I do want the 2's to kind of cancel away right away. So I'm going to use this guy. So the 1/2, this will be equivalent to pi over 3 or 60 degrees. So again, root 3 over 2 divided by the 1/2 is the same thing as multiplying by 2 over 1. 2's are going to cancel out, leaving it with root 3. So what is my theta? So theta is pi over 3. So now what I'm going to do is replace my theta, replace this guy and this guy with the pi over 3. So this becomes sine of 2 pi over 3, cosine of pi over 3, and then the cosine of 2 pi over 3, sine of pi over 3. So now let's replace. So 2 pi over 3, that's in quadrant number 2, and that is going to be root 3 over 2. Cosine of pi over 3 is 1/2, and then this will be a negative 1/2, and then this is a root 3 over 2. So root 3 over 4, negative and negative turns to positive, so root 3 over 4. This is going to give me 2 root 3 over 4. The 2's cancel away, leaving you with root 3 over 2. Now, what you might be thinking is, why couldn't we just replace this guy into this original equation? And the answer is you could have. So we could have just said this, x is equal to sine of 2 pi over 3 minus pi over 3. So we could have used, we didn't have to necessarily use the identity. So this 2 minus 1 is just going to be pi over 3. And what is the sine of pi over 3? It's root 3 over 2. Right? So again, two different ways to solve this problem. Again, sometimes we do want to make sure that we know how to use the identities. Right? So let's solve another one. So this will be example number 2, and again, solve for x. So I'm going to say that this is arc cosine of x plus 2 arc sine of root 3 over 2 is equal to pi over 3. So this is kind of similar to that very first example. So why don't you go ahead and pause the video and try to come up with the answer. Okay, so the first thing that we should have done is moved the 2 arc sine to the other side. So arc cosine of x, pi over 3 minus 2 arc sine of root 3 over 2. And then we are going to apply the inverse to both sides, so cosine and cosine. So this will become x is equal to the cosine of pi over 3 minus 2 arc sine of root 3 over 2. Okay. When we do the second inverse, we want to make sure that we're only taking this part right here, right? So we don't want to include the 2 ever. So I'm going to say let theta equal arc sine of root 3 over 2. So this now becomes x is equal to cosine pi over 3 minus 2 theta. So on this problem, I see a root 3 over 2, so I'm not going to use my identity quite yet. So I'm going to apply the both sides. I'm going to get sine of theta is equal to root 3 over 2. Where is this true? It's quadrant number 1, and our theta has to equal pi over 3. So what I'm going to do is I'm going to replace theta with pi over 3. So cosine of pi over 3 minus 2 times pi over 3. This will be the same thing as saying, actually I'll bring it down instead, erase that part. So we're going to say x is equal to, so 1 minus 2 cosine of negative pi over 3 using our negative angle identity, right? If we use that same one, this would be the same thing as just the cosine of pi over 3, which gives us 1/2 as our answer. Okay. Let's try another one. So let's get a little bit more challenging. All right, so problem number 3. What happens if I have this arc sine of 2x plus arc sine of x is equal to pi over 2? Well, this one's a little bit harder because we actually have 2 variables. So what we want to do is we want to isolate the one that's a little bit harder. So we're going to isolate this guy right here. So I'm going to say arc sine of 2x is equal to pi over 2 minus arc sine of x. I then will apply the inverse to both sides of sine. So this will become 2x is equal to sine of pi over 2 minus arc sine of x. So again, I'm still solving, so still solve for x. Okay, eventually I am going to have to divide by 2, but for a second what I want to do is I'm just going to use my identity because I know that this is not going to be able to subtract. So I'm going to say sine of pi over 2, and well, let's replace this. I'm jumping ahead. Let's do this. Let's say let theta equal arc sine of x to begin with. So minus theta. So then this will become 2x is equal to sine of pi over 2 cosine of theta. Keep the sine. Replace this. Cosine of pi over 2 sine of theta. Now, sine of pi over 2, that gives me 1. So essentially, I just need to know what is the cosine of theta, and then cosine of pi over 2, that equals 0. So this all goes away. So that's really nice. So essentially, I just need to figure out what cosine of theta is and set it equal to 2x. So I'm going to come back over here, and I'm going to say sine of theta is equal to x. All right, well, that didn't help me, but what I do know is that it's x over 1. So this is where it gets a little tricky. We have to remember that this is your y over your r, so we have to think about it in those terms. So I'm going to say that we're missing the x, so I'm going to call the x as a question mark. So that way, hopefully, it's a little less confusing. So we're going to say x squared plus question mark squared is equal to 1 squared. So question mark squared is basically 1 minus x squared. And I'm going to take the square root to both sides. So our question mark is just the radical of 1 minus x squared. When we don't actually know what quadrant we're in, we're going to assume it's positive. So assume quadrant number 1, right? All right, so now I know that that's the question mark. Question mark is x. So coming back to this problem, this will be 2x. So this would have been the radical of 1 minus x squared all over 1. So again, 1 because that was the original denominator, and the question mark really was the x. I don't really necessarily need the 1, so I'm going to go ahead and I'm going to erase that 1. How do I undo a square root? I'm going to square both sides. So square both sides. So this is going to give me 4x squared is equal to 1 minus x squared. I'm going to add x squared to both sides. So I'm going to get 5x squared is equal to 1. Divide by 5. I'll get 1/5. And then I'm going to take the square root. So I'm going to get plus or minus the radical of 1/5, which is plus or minus 1 over root 5, which is just plus or minus 1 over root 5. Multiply root 5 both top and bottom. So root 5 over 5. Now, we have to remember, anytime you have to square something, right, you must check your answers. So anytime you square anything in an equation, you must check the answers. Right? So we want to make sure that we check our answers, right? So how are we going to check, right? So I would say inverse, I'm going to write it like this, inverse of 2 root 5 over 5. And then this will be plus the inverse of root 5 over 5. And I want to know, is this pi over 2, right? So this is our first check. And then the second one will be the inverse, but this time it'll become a negative. So negative 2 root 5 over 5 plus the inverse, negative root 5 over 5. And again, I want to know, is this pi over 2? Now, I don't know about you, but I don't know where root 5 over 5 is on my unit circle. So we should use our calculator. So we would say second and inverse, and I'm going to say 2 root 5, and then all of that is being divided by 5. Close that, parentheses, and then I want to say plus the inverse of sine of root 5 divided by 5. Now my mode is set to degrees, so I know that pi over 2 is 90 degrees, so this should equal 90. So if we press enter, notice that it equaled 90. So I know that that answer works. I'm going to go ahead and I'm going to click on it again, and I'm going to insert some negatives. So I'm going to insert, so second insert, negative, so I just made it negative. And I'm going to insert again, second insert, negative. Go ahead, press answer. Notice I get negative 90 degrees. So what do I know is that this one worked and this one didn't. So my answer is just x is equal to root 5 over 5. The only positive answer. If you want to try one more on your own, feel free. So example number 4, inverse of sine of x plus tangent inverse of 0 is equal to 0. And when you do all of your work, you will get the answer as x is equal to 0. So I'll show that part on one last, I'll show the answer on one last video.